Now we are taking TV signal propagation in detail. TV signals, they are possessing the frequency having 54 to 806 megahertz as a frequency. So this much high frequency is not possible to be sent through the ground waves. The problem is, as the frequency is high, there will be the more absorption by the Earth's atmospheric particles in the ground waves. So it is not possible to send through that. And the second, if we are talking about the sky waves, they are being reflected by the ionosphere layer. But since this frequency of the TV signals is very high, so they won't be reflected back, rather they transmit through the ionosphere. So this can't be applied by the both of this propagation. TV signals having frequency can neither be propagated through the ground waves because of high absorption by atmosphere near the earth, nor they can be sent through the sky waves because of their non-reflection by the ionosphere. These signals can be received or sent if they are lying on the line of sight. What does it mean? That it is lying on the path that is straight path between the transmitting and the receiving antenna. So now we are going to find out how much should be the height of the antenna for the TV, and how much area it is going to cover, how much population density will be following this TV signal coverage, and how much is the line of sight. So this is all we are going to find out. Now we are going to find out the coverage range and the height of the antenna. This is Earth. Let O be the center of Earth. Then this is the radius of Earth. Let at point S we have installed the antenna. This H is the height of antenna. Say P is any point at a distance D from this height of antenna, where we are making the message from this antenna to reach. So coverage range is D and H is the height of antenna. We are going to find out the relation between two of them. Since this is again the radius of Earth, let us join this. Now, if we take a triangle OPL, this is a right angle triangle, so we can apply the Pythagoras theorem. H is the height of antenna, R is the radius of Earth, D is the coverage range. In right angle triangle OPL, OL square is equal to OP square plus PL square. Now what is our OL? OL is equal to RE plus H. This is equal to RE plus H whole square. Now what is our OP? It is RE square. And what is our PL? This is equal to D. So it is our coverage range. Now we have RE square plus H square plus 2REH is equal to RE square plus D square. Now if we look at this, here height of antenna is very less than the radius of Earth. So this factor h square can be neglected in comparison to Ra. So we can, so h square can be neglected in comparison of radius of Earth. Therefore, d square is equal to 2REH, or d is equal to under root 2REH. So, this is the relation between the coverage area and the height of antenna. The next is the area covered by TV transmission. It is given by A is equal to pi d square, where d is the coverage range, and we have found it out, d is equal to under root 2REH. So using this relation that we have found out for d coverage range in the above equation, we have A equal to pi 2REH, or 2 pi REH. This is the area covered by the TV transmission. The next we are going to find out the population covered by TV transmission. This is equal to population density into area covered. So this thing is equal to population density into 2 pi REH. Many times numericals are being asked on the area covered or how much is the population covered by the TV transmission. Now we are going to find out the maximum line of sight distance. Line of sight, already we have mentioned, it is a straight path between the receiving and the transmitting antenna. Here we are having HT as the height of the transmitting. This is our transmitting antenna. HT is the height of transmitting antenna, and DT is the coverage of transmitting antenna. On this hand, this HR, this is our receiving antenna. HR is the height of receiving antenna, and DR is the coverage of receiving antenna. The maximum line of sight will be DM. DM is the maximum line of sight. It is equal to DT plus DR. DM is equal to DT plus DR. This DT is given by under root 2 RE HT, and DR is given by under root 2 RE HR. So this is the maximum line of sight distance that we have calculated.